All right, welcome everyone to this explainer. Today, we are literally strapping in for a completely mind-bending journey. We're going to take what I like to call a cosmic zoom, traveling all the way from the absolute unfathomable edge of the infinite universe, right down to our very own cosmic backyard. But before we really take off, I want you to think about this massive question for a second. What exactly makes up the infinite universe? When you look up at the night sky, you're only seeing this tiny, tiny fraction of what's actually out there. We're talking about a scale so huge it almost breaks the human brain. What is actually sitting out there in all that dark space? So, to put it simply, the universe is just everything that exists. We're talking about all of space, every single star, the planets, the massive galaxies, and even those seemingly empty clouds of gas and dust. It is incredibly large, and honestly, it still holds so many deep mysteries that we're really only just beginning to unravel. Today, we're going to break down these immense scales together to kind of put our whole cosmic existence into perspective. Okay, let's dive into this. Here is our flight itinerary for today. We're going to cover 1. The infinite universe, 2. Galaxies and stellar nurseries, 3. Inside the solar system, and finally 4. The moon and eclipses. Starting right off with Section 1, the infinite universe, our eyes in the dark. To even begin to wrap our heads around a space this overwhelmingly large, we obviously can't just rely on our naked eyes, right? Scientists have to rely on tools like the incredibly famous Hubble Space Telescope. Hubble operates a lot like a super-powered version of our own eyes, taking these breathtakingly clear pictures of stars, planets, and entire galaxies. But, and here's the catch, the universe is hiding secrets that visible light just can't show us. That is exactly where the Chandra X-ray Observatory steps in. Chandra looks at the universe using X-rays. It basically acts as our specialized eyes in the dark, revealing the universe's most extreme phenomena and helping scientists study things like black holes and incredibly hot objects in space. Put them together, and they give us a much, much more complete picture of the whole shebang. Moving on to Section 2, Galaxies and Stellar Nurseries, the macro structures of space. So when we zoom in, we don't just see individual, lonely stars. We find entire galaxies. A galaxy is a huge, sprawling group of stars, planets, gas, and dust, and it's all held tightly together by gravity. And here is the truly wild part. This single view represents just a tiny pinprick of the sky, yet there are literally billions of these massive galaxies scattered throughout the infinite universe. I mean, it really puts our daily problems into perspective, doesn't it? Now, among all those billions of galaxies, we actually have our own cosmic address, the Milky Way. This majestic spiral right here, that's our cosmic hometown. It contains billions of stars of its own, and somewhere tucked away inside one of those spiraling arms is our very own sun. And in the vast spaces between those billions of stars, we find these vibrant, colorful formations known as nebulae. A nebula is essentially a massive cloud of gas and dust just floating in space. But it's not just a pretty space cloud. These are actually stellar nurseries. The gas and dust in these regions clump together under gravity until they ignite, literally giving birth to brand new stars. It is kind of like the universe's ultimate cosmic recycling center. All right, Section 3, Inside the Solar System, our cosmic neighborhood. Arriving at a much more familiar scale, we find our solar system, which is basically the sun and all the objects that move around it. You can think of it as our local cosmic house. Everything in this house, every single planet, every asteroid, every comet, is anchored entirely by the massive gravitational pull of our central star. And sharing this cosmic house with us are 7 other distinct planetary neighbors. So in order from closest to the sun to the furthest out, we've got Mercury, Venus, our beautiful home Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But the really crucial point here is how this all functions together as a dynamic system. These 8 diverse planets don't just sit there frozen. They are constantly in motion, moving and orbiting around our central star in this perpetual gravitational dance. Each planet has its completely unique environment, sure, but they are all inextricably bound to that exact same fiery anchor in the center. Which brings us to our final zoom in, Section 4, the moon and eclipses, our closest companion. Zooming in from the whole solar system directly to our closest celestial companion, we actually have to establish a super fundamental mechanical point first. The moon does not produce its own light. I know it looks incredibly bright on a clear night, but it's essentially just a giant rocky mirror hanging in the sky, reflecting the sun's light back down to us here on Earth. And because the moon is always moving around the Earth, the angle of that rocky mirror relative to the sun is constantly changing. As it orbits us, we see different amounts of its bright sunlit side. This shifting geometry is exactly what creates the lunar phases we're also familiar with. It cycles from the dark new moon to a sliver of a crescent, up to the first quarter, that bulging gibbous phase, the bright full moon, and finally the last quarter before starting the whole sequence all over again. But here is where things get truly spectacular. Sometimes the orbital mechanics line up just perfectly. During a solar eclipse, the moon travels directly between the sun and the Earth. Now, even though the moon is vastly smaller than the sun, it happens to be just the exact right distance away to perfectly block some or all of the sun's light from reaching certain parts of our planet, casting this absolutely breathtaking daytime shadow over the Earth. It's an incredible, almost unbelievable display of cosmic geometry. And what's really interesting is that this cosmic shadow dance actually works in reverse too. While a solar eclipse happens when the moon blocks the sun, a lunar eclipse is the exact opposite alignment. In this case, the Earth comes directly between the sun and the moon. Our planet's own shadow falls onto the lunar surface, making the moon look incredibly dark, or sometimes even bathing it in this haunting, beautiful reddish glow. Looking at all this, from the edge of the known universe all the way down to the shadow of our own little planet, it really brings us to a quote from our source materials that perfectly encapsulates everything we've just seen together. The universe is vast, mysterious, and beautiful beyond imagination. We've zoomed from the completely incomprehensible scale of billions of galaxies, down through stellar nurseries, into our own solar neighborhood, and watched the intricate dance of eclipses. It is a system of just awe-inspiring beauty. Which naturally leads me to this final thought for you. Knowing how beautifully vast and deeply intricate our universe is, and knowing that powerful telescopes like Hubble and Chandra are only just scratching the surface, what other incredible mysteries are out there, just waiting for us in the dark? I really encourage you to keep exploring, keep questioning, and above all, keep looking up at the night sky. Thank you so much for joining me on this explainer, and I'll catch you next time.